In this example, we want to prove that triangle ABC is congruent to triangle EDC. Now, we have to prove it by one of the congruence reasons. So let's just rule out a couple. RHS, right angle hypotenuse side, there's nothing that tells us there's a right angle hypotenuse or side present, so we can automatically rule that one out there. If we look a little bit further into information we've been given, we can see there's two sides here that are congruent, and these two sides that are congruent belonging to both of the triangles. So it looks like there's going to be two sides within this, and there's no third side, so we can get rid of that one there. Side, side, side. Because there's two sides, it looks like it's going to be the second one. There's no two angles shown or given to us, so it looks like it's going to be side, angle, side. And the reason why I say that is because within this diagram, we can see that if these lines intersect, there's going to be a common angle at C, and we know that's vertically opposite. So that tells us it's going to be side, angle, and then side. So we can go ahead with our proof. Alright, so we need three reasons. So if we start off with one of the sides, we can simply say AC is equal to EC, and that's given to us from the diagram. We're making sure our order is correct. And the angle here, now you could, if you said angle C, that's a bit too general. We need to be a little bit more specific with which angles we're talking about. So we're going to say angle ACB, which is this angle here, ACB. This is the angle. Okay, that's what we're talking about. If it's ACB, we start with this point going towards C, then we're going to be talking about ECD. Okay, that's the correct order. Angle ECD. And this here is vertically opposite, so we can just go ahead and put our code. So that's one side, an angle, and the final side is, we're looking at BC is equal to DC, and that's given. Now we just need to end off with the original statement. Triangle ABC is congruent to triangle EDC, and the reason is side, angle, side. Okay, so we've gone ahead and proven that for question A. Okay, so now that we've proven that these two triangles are congruent, we can actually answer the second part of the question. Hence, prove that AB, and this symbol here means parallel, it's just said that in the brackets here. AB, so we're proving that AB is parallel to DE. Okay, prove that those are parallel. So now that we know that these two are exactly the same, these two triangles, that means we can say that this angle here, angle ABC, is the same as angle EDC. And you actually notice here you have alternate angles, and we can say the same for the other adjacent angles too. So because these here are alternate angles, remember, if you have that scenario happening, that means that there is a pair of parallel lines present. So this is the transversal, and these are the parallel lines with alternate angles. You can also say that for this other side here as well. Alright, so we're going to say, hence prove, yep, so angle ABC is equal to angle EDC. And the reason for that is the alternate angles. And then we can say, therefore, AB is parallel to DE, and we can say that because of the alternate angles which we've just given above.